Okay, for question number 24, it's asked when and where does a rainbow appear in the sky? So this is question number 4, and the solution for when. When does a rainbow appear in the sky? So it is formed after a rain shower. So answer for this is it is formed after a rain shower when drops of rain remain suspended in the air. So when. Now where? So where means it is always formed in a direction opposite to that of the sun. So it is always formed in a direction opposite that of the sun. Okay, now we have to draw a labeled ray diagram to show its formation. So we know that the raindrops they act as prisms. So let this be a spherical raindrop and let this be a white beam of light. Now let this be point A where it enters, and here there is dispersion. Dispersion means we get 7 colors which are violet, indigo, blue, green, yellow, orange, and red. So I'm going to show the most scattered and the least scattered color which are violet and red. So at this point it's dispersion. This is the dispersion splitting of white light into 7 colors, and at this point it's the reflection, but it's inside the drop, so we call it internal reflection. So this is internal reflection. We also call it total internal reflection. Now, at this point, that is the point C. So this is point B where the total internal reflection is happening. And at point C, there is a refraction. So the light rays are coming from the water into the air. So this is the reflection. And let's give the direction. So at this point, this is the reflection. So these are the three phenomena involved in the formation of a rainbow, and let's label it as this is the ray diagram for the formation of a rainbow. Okay, now next is what is scattering of light. So we know that when light it enters the air, so when it enters the air, there are particles of different sizes, and the very large size particles or the molecules, which we also call the collided particles, they scatter the light in different directions and change the direction of propagation of light. So we can say that for this, we can write what is scattering of light. For scattering of light, our definition will be, so scattering of light. And for scattering of light, our definition is the phenomenon. So this is the phenomenon of the change in the direction of propagation of light. And this change in the direction of propagation of light is caused by particles of large size. Is caused by, we can say that the large sized molecules or the collider particles that remain suspended in air. So this is what is scattering of light. Okay, now what is the next part? Why does the sky appear blue? So it appears blue because of the scattering of light. And now here, so this when sunlight, so for this our answer should be when sunlight it passes through atmosphere. Okay, Now there are particles of different sizes, but in this case we are going to consider only the very fine particles. So this very fine particles, their size is of the order of the wavelength of blue color. So very fine particles, which we say the very fine particles or the minute particles in they pass through the atmosphere. Now fine particles. So when sunlight passes through the atmosphere, very fine particles in the air, they scatter. Now they scatter light of shorter wavelength, which is blue, because their size matches with the order of the size of the blue light. So light of shorter wavelength, which is blue color, and we can say more than the red color. So blue is scattered more than the red color, which is of longer wavelength. So this is the reason. So red has longer wavelength. So when sunlight passes through atmosphere, very fine particles in the air scatter light of shorter wavelength, that is blue color more than the red color, and that is sky. That is why sky appears blue. Okay, this is the answer for question number 24. Let's move on to the next question.